Hello, so let's talk about the k factor of n. So you're given two integers, one is n, the other one is k. So a factor of integer n is defined as integer I where n mod by I equal to 0. So it has to be, so all of the factor of n sorting in ascending order return the k factor in a list. So one of the easy solutions is like you traverse from 1 to n, and then you mod by, so you n mod by I equal to 0, and then you decrement k, and then if k is actually equal to 0, then what do I have? So if k equal to 0, then we return I, because this is the k factor in the list, right? So if not, we return -1. So in this solution, it's pretty straightforward, and then let's just stop coding, and then we will make another two optimal solution later on. So for in I equal to 1, I less than equal to n, I plus plus. So if n mod by I equal to 0, and then you want to decrement your k, if decrement of k equal to 0, you want to return I, and then later on you return -1 because you cannot find it, right? And submit. So maybe just a little bit improvement for this solution, just doing like this, yeah. So this is like the first solution. So time and space, straightforward. Time is all of n, space is constant. So using this idea, like imagine you have a list. So you have a list to store when n mod by I equal to 0, right? But we don't need to traverse all the way to n. This is because, you know, everything multiplied by 2 is pretty, how do I say this? It's a factor for this, right? So from 1 all the way to 12, you have 1, 2, 3, 4, 6, and 12, right? But we know 6 multiplied by 2 is 12. So basically we can just get rid of, you know, the rest of that, right? So in this case, like if we can tell 1, 2, 3, I believe you can guess 4, 6, 12. Using the other math solution, it's going to be the n divided by, so n represent 12. So 12 divided by 3, you get a 4. 12 divided by 2, you get a 6. 12 divided by 1, you get a 12, right? So this is the order. It depending on your k, right? So in this solution, we only need to traverse what? The first 3, and then we can get the last 3, right? So based on this idea, and we also need to consider the k as well, because if k is greater than the size of the list, then you definitely it's not valid. So imagine this one, k equal to 4, but your list is 3 elements only, so you will return -1. Alright, let me start coding for the second base. So second base is this one. So I have a list, I store an integer, and I'm going to say list. And I only need to traverse from 1 all the way to math square root of n and I plus plus. So if n mod by I equal to 0, I decrement my k. If decrement my k equal to 0, I return I. Else, I'm going to add the value into my list, and once it finished, I still not return anything. I need to make sure what's my middle value. So middle is actually represent what? This guy, right? But this is method square is double, you need to convert to int. You want to make sure also mid value times mid value equal to n. If this is the case, you need to increment your k. So let's think about this. So if n equal to 9 and your k, let's say, equal to 3, so we know the factor of 9 is what? 139, right? Alright, let's traverse the loop. Let's call it. So from 1 to what? To 3. From 1 to 3. I can go from 1 to 3. So 9 multiplied by 1 equal to 0. Okay, so this is 1. So I decrement my k become 2. And then it's not returning, right? So I add it into the list 1 right here. So 2, 9 multiplied by 2 does not equal to 0, so I skip. So 9 multiplied by 3 equal to 0. And I decrement my k, so this becomes 1. So let's start add the 3 into the list, right? So 1 and 3. So I still, I still not returning, right? So I break out the for loop because the next increment should be 4. So 4 is greater than the square root of 3, right? So you break out the for loop. So let's look at the mid value. Mid value represent what? 3 times, meta squared n. So which is meta squared 9 equal to 3. 3 times 3 equal to n. So you increment your k. So k was 1, so you increment k equal to 2. Alright, so now what we need to do is we need to make sure our k is less than or equal to the size of the list, right? So if k is greater than size of the list, we know that this is not a valid. This is not a valid k, we return -1. Else we need to return. So we need to return n divided by the value in here, right? So the value in here is going to be what? The size, so it's going to be list.get size minus k. So in this case, n equal to 9, k equal to 3 in the beginning. So I need to return 9 because this is how it is, right? K equal to 3, you want to return 9. But my k current case is 2 right now, and my size is what? My list of size is 2. So 2 minus 2 is 0, so you want to return 1. So 9 divided by 1 equal to 9. So this is supposed to be a reverse idea of getting the value. So if k is greater than the list of size, you want to return -1. And else you want to return n divided by list.get list.size minus k. So if you don't understand, this is like a pure math stuff. So yeah, you can combine this into one line, it doesn't matter. But alright, let's talk about time and space. Time, this is going to be all of square root of n, and space, this is going to be square root of n, right? So this will be, a little bit improvement compared to the last one. And there's another one which is better. Like since you traverse from beginning to the square root of n, you can actually traverse back from square root of n all the way to 1 to get the factor, to get a k factor. And let's see, let's do this. So for in I equal to 1, I less than max.square n I plus plus, and then I will say if n mod by I equal to 0, I will decrement my k, and if k equal to 0, I return I. So if you notice, I don't have an equal sign over here. This is because I will have to have another for loop to traverse back. So greater equal to 1 and minus. So yeah, a little bit like difference is why do I not keep an equal sign over here? This is because first of all, I will have a traverse, the reverse for loop back from this position. So I don't need to care about the equal sign. If I have an equal over here, I will traverse the same value twice. So this is not allowed. Alright, so once I have that, I'm going to say if n mod by divided by I, and if this is equal to 0, and you want to subtract the k equal to 0, then you will return the n divided by I. So yeah, this is another way to write to make sure the remainder is actually 0. I mean, you can definitely say n divided by I, but in this case, if the n is big enough, okay, n is small, but this is more secure. And yeah, if everything else, just return -1. So hopefully it makes sense. But if it doesn't make sense, comment your question below, and let's talk about time and space. Time is square root of n, time is square root of n, space is constant. So if you have any question, leave a comment, and I will see you later. Bye.